Hi guys, today I'll be going over a question from lesson 5.3. In this question we're given three charges, A, B, and C. The charge on A is negative 1.5 coulombs, B is unknown, and C is negative 0.64 coulombs. So the question for part A is asking what is the charge of B, that's what we're looking for, in order so that A is in equilibrium, or it has a net force of 0. So we're also given the distances between A and B, which is 0.6 meters, and the distance between B and C, which is 0.4 meters. So the only two forces acting on particle A is the force exerted by B and the electrostatic force exerted from C. So we can calculate the force on A by C using Coulomb's law, which we learned is K QA times QB over R squared. And the R is just 1 because 0.6 meters plus 0.4 meters is 1 meter, which is the distance between A and C, which is equal to 1.5 times 0.64 over 1 times K. And this is a repulsive force because they're both negative. So let's just calculate that for a sec. You can see 1.5 times 0.64 times, and we know K is 9 times 10 to the 9th. So that's equal to 864, or actually we don't even need to plug in K, so divided by 9 times 10 to the 9th. We'll just call it, it's equal to 0.96 K. So that's the force of A on C, and it's repulsive. So we already know that B must be a positive charge because it has to counteract the repulsive force exerted on A by C, which means it has to be attractive. So FB is equal to K QA QB over R squared, which is equal to, and actually we can just write it as K QA QC over R, and this is a different R, so it's A to C, and this is A to B squared. So, we should have just started with this equation, because here we can cross off the K's, and we can also cross off the QA's. So we're left with the charge of B over, and the R squared is that 0.6 squared is equal to the charge of C, which is 0.64 over 1 squared. So charge of B is equal to 0.64, which is the charge of C, times 0.6 squared, which is equal to 0.23, and it's positive, like we said, because it attracts charge A. So and then part B is asking if we're trying to find the F net equals 0 upon charge C. So, like in the previous part, we know the distances between all the particles. So this is A, B, and C. Okay, so if F net is equal to 0 on charge C, then we know F, the force of B on C is equal to the force of A on C, like magnitude-wise, because F net equals 0, and those are the only two forces acting upon it. So that's K QB QC over R B to C squared is equal to K QA QC over R A to C squared. And the distance between, so we can cross off K on both sides and C on both sides. So QB is equal to QA over R A to C squared times R B to C squared. So now we just plug in numbers. So we know the value of QA is equal to 1.5. We also know that the radius, or the distance between A to C is 1, so we just ignore it because it's 1. And then we also know the distance between B to C is 0.4 squared. So that's equal to 0.24. And we also know that coulombs. And we also know it's positive again because A and C are negative. So that means that A is repulsing C. But in order for B to counteract that, it must be attracting C. And interestingly, 0.24 coulombs for charge B and 0.23 over here, they're pretty close, so it must just be a numerical rounding difference. But that means that this system makes sense because in order for it makes sense for the system to exist in static equilibrium at the distances provided in the problem. Because if we calculated different values, that means the system could not be in equilibrium at the distances that were listed. Thanks for watching.